you have to process more information. There is a higher demand, even in power conversion and motor control, to process more information. You are sensing more, you are doing gyroscope, you are doing this and that, and security, and all kinds of safety, and all kinds of different things, right?
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. I'm your host, Kelsey Markl. Today, we're speaking with Marijana Vukicevic, who is Director of PSOC Control at Infineon. We're going to be talking about a new family of microcontrollers that helps meet the industry's demand for faster processing, more power demands, and higher security. Marijana, thank you so much for joining us.
Thank you for having me in your podcast. That's a privilege. My name is Marijana Vukicevic. I'm a product marketing director for our new line of products called PSOC Control C3.
Thanks for taking the time. I know it's a little bit early in your time zone because you're located in our El Segundo office, right?
Yes, that is correct. So it is a little bit early, but we start very early. So basically 8 a.m. is not too early for us. We work with different regions. We work with Germany a lot. So we wake up really early to work with our colleagues efficiently.
Okay, good to know. And I mentioned it in the intro. We're going to be talking about PSOC Control a bit. But before we get started, I know that you have been with Infineon for several years. Do you want to tell us a little bit about your background with us?
So I joined Infineon in 2018 as a product marketing for battery-powered applications. And down the line, it made sense for me to move in a direction of controllers with when we bought Cypress. So
that was in 2020, right? So
that was in 2020. Yeah, I think I think we started the basically into 2019, and then it was closed in 2020.
Okay.
And then it was a natural step for me to after dealing with battery powered applications on a integrated controller side, it was a natural step for me to move to the Cypress side when we acquired Cypress and work directly on the controllers and the full ecosystem for the controllers in power and motor control applications, because this is not a IoT or edge, but we are specifically focused on what is the natural character of Infineon, and that is essentially power.
Okay, that's a really good point, because I know with the acquisition, we brought in a lot of know-how and expertise in the microcontroller space and combined it with our power expertise at Infineon. And that is kind of what has happened with PSOC Control, right? Can you tell me a little bit about the microcontroller?
Yes, that is exactly what happened with microcontrollers. When we acquired Cypress, we were thinking we wanted to create a new line of microcontrollers, right? And we were thinking, what is it that we wanted to do, and what is exactly what we wanted to achieve with the abilities that we had currently. What we figured out very fast was that demands in the market and from our customers were such that it was going to be very beneficial for us to combine IPs from XMC, the previous family that we had at Infineon, and new technologies that Cypress was introducing to us through their families, for example, like PSOC 6 and some previous families they had. Cypress had a long history of microcontrollers and a huge library of IPs, fantastic processes for the design. And we have decided that we were going to use the most advanced technology for us to address the power conversion and motor control markets.
Okay, and you said what makes this family unique is that it really addresses motor control and power. What is unique about these applications? What demands are unique to these applications?
The demands that are unique to these applications, and that is what we were trying to solve when we acquired Cypress, were um, fast processing of the information, because we have something in the systems that is a closed loop. We have to send something, the real world, do something with it, and process it further. And then we had also a demand for higher efficiency. So we try to figure out how are we at the system level going to help with our controls increase the efficiency. And then the last one would be, we see more and more security and demand for security. We Some 5 years ago in power and motor control, security was at the bottom. No one talked about security. Today, I think at least 50% of the market talks about some level of security, if not more. And in the future, even higher levels of security. So security for us is also a very important topic.
Okay, yeah, I know with a lot of other applications, they have similar demands, efficiency, and scalability, higher processing, faster speeds, and usually our solution to that is to digitalize them. Is that the case for microcontrollers?
Yes, this is definitely the case for microcontrollers. So when I started my career, the world was completely analog. The only part of the digital world was whatever the processors were used on the motherboards for computing. Today, the world moves so much in power for the in digital control. Why digital control? Why the digital control is so important? Um, with digital control, the demand for digital control is important because you have to process more information. There is a higher demand, even in power conversion and motor control, to process more information. You are sensing more, you are doing gyroscope, you are doing this and that, and security, and all kinds of safety, and all kinds of different things, right? And for that reason, you do have to have more processing power. Analog, if you created everything in analog, the board would be huge. The only way to shrink and to make it small is if you actually realize all of these functions in digital spectrum.
Okay, yeah, I can imagine if you just think about a factory, a traditional factory, a robotic arm or some other drive application, they used to just do one simple thing. I don't know, up and down, and now you
Yeah,
have 360 degrees, like you were saying,
yeah,
sometimes a gyroscope. That does
yeah,
sound like a lot of information.
yeah. To that.
Are there any other benefits to going digital when it comes to the design process, perhaps?
Yes, there are lots of other benefits. I mean, that was one that we mentioned, but there is really a lot of them. So one of the benefits is also scalability for our customers, right? So our customers don't have to change the platform they're working on if they use digital way of realization of their systems, right? So what that means is they can continue to use the same, for example, microcontroller. They can only change the software, right? Scalability with the customer is also much bigger when they shift it to digital. The design cycle is faster. The ability to come up with the new products in the market is faster. So, and basically the world is moving much faster than it used to move like 30 years ago, or 40 years ago. So in power lagged a little bit behind the rest of the world moving from analog to digital. But today, I mean, digital is taking over power.
Okay, so moving more away from hardware based design upgrades to software based, then to get
Yes.
digital.
Yes, that
Okay.
is correct. It's easier, so software is faster to develop. I mean, there are definitely how would I say that, obstacles, in software development and all that. I mean, the testing also needs to be done and all kinds of different things, but still it's much faster.
Okay. Going back to the applications, we already mentioned the robot arm or motor drives. Can you provide any examples for really specific things where we can find PSOC control?
So we do. We can find them. We can find a piece of control in many applications. We have really, but what I would like to mention is that today, in order for us to be to show the value to our customers, we like to pair our piece of control with GaN switches.
Okay.
So what is that plays into that specific role where we mention efficiency, right? So the systems, all of the systems, whether they are battery powered, whether they are in the data centers or anywhere, all of the systems have a requirement to be much more efficient. The energy, everybody today talks about energy one way or another. We have to provide the value of higher efficiency. That's why we are pairing with GaN. So what's specific about piece of control and GaN, right? So why piece of control with GaN? We have some specific features that are inside the microcontroller that are supporting fast operation of GaN. So GaN is switching very fast. So those switches are much faster than MOSFETs, and you have to have the functions inside the microcontroller that would help and provide fast switching for GaN.
Okay, so I guess then this line of digital microcontrollers makes a lot of sense in all applications where GaN would make sense. We have anything. We talk a lot about silicon carbide on the podcast. GaN is definitely an up and comer technology that has definitely a role and has fast switching applications. So I assume this would be things like home appliances.
It would be home appliances. It would be vacuum cleaners. It would be home robots. It would be power supplies in the data centers. That's a very hot topic. It would be e-bikes. It would be air conditioning outdoor units. It would be it's really wide spectrum. It would be even lighting. It would be just really quite a bit of applications wherever you see the power needed, right? So essentially, wherever you see the power, most of the time the power is controlled digitally. So whenever we need power, and we need pretty much in all the electronics around us, that's where you can find us.
You did mention a few things that are battery powered. I recognize. So e-bikes, and I guess they have slightly different demands for energy efficiency than your regular power control.
They do have slightly different demands for the energy efficiency. For example, devices like handheld vacuum cleaners or power tools or e-bikes, you don't have to use them every day, right? So you leave them aside for some time, and then in that case, you don't want your battery to leak, right? So basically, next time when you take it, you don't want the battery to be empty, and you can't really use it immediately. So for that, you really want to save as much as possible your battery, and your microcontroller needs to take a state where that battery won't leak. That minimally it will be using the energy. So just it's so little awake that if you take your bike, basically it can wake up. So, and we have created a function inside the power control function, inside the power mode function, inside the microcontroller that uses very little of the energy. I think probably it's a benchmark in the industry for very low power in hibernation.
Solving one of the most annoying problems when you go to your battery operated vacuum and the battery is out.
Oh yeah, that's annoying, very annoying. Yeah.
Okay. I think whenever we were talking a little bit earlier when we met to talk about this episode, energy efficiency, we've mentioned it several times. The demands for more energy efficiency is constantly increasing, right? How are microcontrollers enabling this, especially the shift towards digital microcontrollers enabling this demand for more efficiency?
So there are different ways how they're enabling that, and one of the ways, as I mentioned, is through enabling usage of the fast switches, right? So, and these fast
So the GaN
switches,
switches, yeah.
the GaN switches, right? So not every microcontroller can run GaN, right? So essentially, what we do, we have created some of the analog IPs inside our chip that are actually very fast in sensing the things from the outside world and feeding it back again to, for example, power supply. So how does that work is you have the, for example, power supplies in data centers, and current efficiency of these power supplies is approximately between 96 and 98%. The whole world is moving toward 99+%, because at a data center level, if you use a percent, that's a huge amount of energy and money for data centers. And with AI, right? So AI, everybody's talking today about DeepSeek and OpenAI, and who's using more chips, who's using less chips, and so on and so forth. More chips, more power supplies, more energy, right? So that means that basically what we are trying to do is we're trying to increase the efficiency at every single power supply to be able to meet the demands of the future and of AI, right? AI demands, and I mean, it's not anymore whether we're gonna use AI and how. It's when is it going to be completely available in our everyday life. We are trying to prepare for that. And with that, also what's happening is, and that's another topic that we can probably touch a little bit, there is a higher demand for higher security.
Mm-hmm. Tell me about more security. What does this mean in terms of microcontrollers?
For higher security, that's very interesting. So what we are seeing is demand for in power supplies in data centers for higher security, right? So they want to make sure that basically they can do the over-the-air updates on the software in the microcontroller, in the power supply, without being hacked.
Okay.
Right?
And these digital microcontrollers enable that.
So essentially, we have we enable it. We create, so that's the strategy that we had from the get-go, right? When we acquired Cypress, we are going back again to that. When we acquired Cypress, we were trying to figure out what are the biggest demands in the market, right? And what is it, the architecture that we should use for the future? We had Cypress, we had their technology. We relied on that technology that Cypress has been using over many years, and essentially chose the modern architecture from ARM. And that modern architecture from ARM was called, the core, ARM core is called M33. M33, the core itself, is an architecture of the whole environment, is allowing the higher security to be deployed on these MCUs.
Okay, so with PSOC Control and a lot of other advancements in technology, we can expect AI to at least become more efficient than it is now. Yeah, sure. That's great. So thank you so much, Marijana, for taking the time to explain the shift towards digital microcontrollers to me today.
Thank you, Kelsey, for having me here, and looking forward for our next one.
Yeah, and to our listeners out there, please be sure to stay tuned to the next episode. We'll be continuing to tell you how semiconductors are decarbonizing and digitalizing the world. Thanks so much.